The next data structure we are going to analyze now is about linked list, which is also a kind of a data structure which we saw for array, for stack, for queues, simple list. The similar way we have it over here, which is called as a linked list. As I mentioned, linked list is also a data structure, but it is a sequence of data structure which are connected together via links. So as the name comes like linked list, it means that there is some association of links in this data structure. So we have a structure of data which is mentioned in a particular sequence and they are connected to each other with the help of links. So linked list is a sequence of links which contains items. So there are various items, or we can say in simple terms, they are also called as the elements which are included in that particular list. So we have a sequence of links with association to these elements, we can say in that manner. Each link contains a connection to another link. So we have association in such a way like one link, or we can say one link is connected to another link, and this association is done with the help of the particular element. So linked list is the second most used data structure after array. So as you remember in the previous chapters while explaining for array, I did mention the point that array is maximum used like for the terminology perspective or say algorithm perspective. So in the similar way, after array, the second most used data structure is the linked list. So let's analyze the structure of this linked list. Like we have the various operations, also the structure of linked list. So as such, it is important to analyze the structure as well as the various operations associated with linked list. This chapter is a complete focus about understanding the structure and the various set of operations which are included in the particular linked list. So I can say now linked list is nothing but we have elements associated with it and some kind of linking with respect to this particular elements. Like one link is associated to another link. So this is the basic terminology when it comes to linked list. Next, after this comes the next thing is understanding about the various terminologies. So we have basically three terminologies when it comes to linked list data structure. First one is the link. Each link of a linked list can store a data called as an element. So it's like every link of the particular linked list, like every items are associated, or we can say every elements are associated with the help of link. So this link of a linked list can store a data which is called as an element. Like what item we call now, this can also be called as an element. So this is the first terminology about link. The next is next. Next means what? In simple layman terms, next means the next item or the item which we have after that. After that, what will be the associated element or the item? So that will be called as the next element. So each link of the linked list contains a link to the next link. So it has a link which is associated to the next link from the existing one. So which is called as the next. After this comes the terminology which is called as the linked list. A linked list contains the connection link to first link called as the first. So we have linked list which contains a connection link to the first link, and from onwards it will have a link associated to the next element. So in this way we have a structure for linked list. Let's understand the structure also for linked list. So if you say structure for linked list as given in this diagram, if you check it out, we have something called as a head, there is a node, and some data items are associated to it. So these data items are nothing but the elements which I mentioned in my terminologies. Every element has the next link, and this next link is associated to the other data items, and the data items have the other next link, and so on. The element structure goes on in this way when it comes to linked list. So linked list contains a link element called first. So you can say that as the head element. Each link carries a data field and a link field called as the next element. So this is what is my next element. After this comes each link is linked with the help of next link, and that is associated over here with the help of data items. So last link carries a link which is called as the marker with the null value. So last link carries a link as null to mark the end of the list. So this is what is the basic structure for understanding the linked list. In simple terms, I can even say this is the simple linked list or a singular format of a linked list. There are also different type of linked lists which are also called as the doubly linked list and circular linked list. So doubly linked list is like the first element has association with the next element and so on, and when it reaches the last element, it again gets associated to the first element. So that is like having the double connection, so that's why we call it as the doubly linked list. We can also say that the items can be navigated forward as well as backward. So it is not like the end of the linked list we reach when it comes to doubly linked list. Whereas in case of singular, or we can say circular, singular we saw for now, but circular linked list, last item contains a link of the first element as next, and the first element has a link to the last element as previous. So it is like in the circular format. So that is why it is called as the circular linked list. So now the next association comes is to understand the basic operations for linked lists. As we have seen for queues, for stack, arrays, and many more data structures in our previous chapters, the similar way we will have for the basic operations formalities when it comes to linked lists. So first one is the insertion. We have insertion means that it adds an element at the beginning of the list. So whenever it comes to linked list, it is always in the beginning of the list. And when we delete a particular element, say for deletion operation, so deletes an element at the beginning of the list. So it is like every associative operation in linked list starts from the beginning of the list. Then comes display. So display displays the complete list, what the list has associated with the elements and the nodes. So that is the association when it comes to display. After that comes search. Searches an element using a given key. When you search a particular element with the help of a given key, you should get the value associated to it. So that is done with the operation of search. After that comes the last operation, which is respect to delete, which is like deleting an element using a given key. So let's focus on two major operations of linked list. So that comes into a picture which is called as the insertion and deletion. Let's understand with the insertion operation. So as I mentioned, insertion is adding a new node in a linked list, and it's more than a one-step activity. It is not like in the similar way like we have it for arrays, stack, and queues. It is completely different when it comes to logic point of view while inserting a particular element in linked list. So adding a new node in linked list is more than one-step activity. So we'll go here in scenario-wise with n number of steps which are involved in it. So we shall learn with the help of diagrams for understanding insertion operation in linked list. Here what happens, first thing is that it creates a node using a same structure and finds the location where it has to be inserted. So that is the first step. So when it comes to step number 1 for insertion, we have the head tag and the node which includes the data items and next. So first it checks that we need to create a node using the same structure. So it copies the same structure and finds the location where it has to be inserted. So this is our linked list. My new node is this one and I have to insert this node inside my linked list. So first thing it does is to check whether the location is there for the new node. So imagine if we are inserting node B, then between node A and node C, consider this as A and C, then point B should be next to point C. So in this way it should work. After this comes the step number 2. Step number 2, what it does, it finds out the appropriate location. So it checks that, okay, fine, this is the first node and after this comes this node and which points to null, which means that this is the end of the linked list. So what it does, it enters a new node B which is next to C, or you can say B in middle of A and C. So it checks for this structure, like it can be inserted in the first manner or in between both of them. So now the next node should point to the new node. So that is the structure basically done. After this, you need to check that the next node at the left should point to the new node. So whatever the new node which we have in the left structure, it should point to the new node. So we should include element in such a way that it is inserted in the first, you can say list only, but it should point particularly with respect to the first node structure. So step number 3 is like it checks for the scenario like, okay, this node can be inserted over here, and after this we can include one more node and the last node which will point to the null pointer. So once the nodes is inserted, the last structure, like after insertion, the final structure for linked list would look in this manner. So like we will have the similar steps which will have association when it comes to deletion. So let's check for the deletion operation. So here deletion step number 1, it does the same thing. So deletion is also more than one step process. So we will learn this with the help of the pictorial representation. So first locate the target node. So target node to be removed by searching search algorithm. So target node to be removed is not like a rapid node which is automatically generated by the user like, okay, I have to remove this particular node. So this is not a scenario over here. We have certain set of search algorithms which we will learn in the upcoming chapters, like various type of the search and sorting algorithms. So based on that algorithms, it is decided that which node to be removed in the particular list. So once it is checked, like, okay, I have to remove the left previous node of the target node should now point to the target node. So suppose if I say, this is my target node to be removed, then in such a way, this particular link, which is it associating to the last, should be now pointing to this one. So it should go to step number 2 in such a way that this next link which we have, so this pictorial representation will give you a better imagination or the scenario for understanding the deletion process. So now we have this next node. So this next node should point to this one. Now this is going to be removed. So whatever it is associated with the linkage of nodes, now this one should point to this one. So once the target node is now removed, the last step would be to understand that there is no dependency. So in this case, we can say that this will remove the link that was pointing to the target node, and we need to target only the deleted node. So we need to also check with respect to the memory usage, or we can keep that in memory. Otherwise, we can simply delocate the memory and wipe off the target node completely. So it checks for any kind of the dependencies. If there are no dependencies, it is removed. And after this comes your linked list in this particular manner, like there are only 2 nodes, the middle node is removed, or we can see it was deleted, and automatically the head is pointer to the first node and this next node is pointing to the last node, which is automatically pointing to the null pointer. So this is the basic process for understanding the linked list procedure. So this was about understanding with respect to insertion and deletion. But there are also various kind of scenarios which come into picture when it comes to linked lists. The basic thing for introducing linked lists was to overcome, we can say, the shortcomings of an array. So there were several reasons arrays are not always the best data structure to use for organizing data, although it is the topmost data structure which is used by all the programmers nowadays. But there were certain kind of, we can say, cons which were listed, and to overcome that particular set of shortcomings or cons, we introduced a data structure which was called as the linked list. So many programming languages, we can say array is of a fixed length. So it is hard to add a new data when the last element of the array is reached. Adding and removing data from an array is also difficult because you have to move array elements up or down to reflect either an addition or a deletion. However, these programs or these set of problems do not come up with JavaScript array, since we have to use a split function without having to perform any additional array element access. But to overcome this particular one-dimensional array model, we have this introduction of linked list where it follows a procedure when it comes to any kind of operation, say for insertion, say for deletion. It follows a particular algorithm or a typical protocol, and based on that protocol only, it designs the operation, like what should be inserted and what should be deleted. Now in the next chapter, we will analyze the complete thing like a linked list, which is also called as the collection of objects with the help of nodes. So how are these nodes created? How are various methods associated to nodes, like which one is to find, which one is to say get the next element, and which one we can say is actually designed for getting the previous element or searching a particular element in the node structure for linked list. So let's move on to our next chapter, which is understanding the implementation of linked list with the help of JavaScript.